Dave's notes were just almost an overview of the whole chapter, to be honest. Before I actually jump into this, I do want to say one thing about Rolle's theorem and mean value theorem over the past 2 days, because on your quiz are critical points, absolute maxes and absolute mins, and Rolle's theorem and mean value theorem. And actually, after we got through the day yesterday, it kind of dawned on me that the mean value theorem versus Rolle's theorem, actually, you do the exact same thing. In that, number one, the preliminary information is, in order to satisfy being even open to the mean value theorem or Rolle's theorem, is that the interval has to be continuous along the closed, so the bracketed version, so that's one. And then the interval in both cases, or the function has to be differentiable along the open interval. You know, it could never be differentiable along the closed interval because nothing is differentiable at endpoints. So if you have those endpoints and you're including those endpoints with brackets, nothing's going to be differentiable along a closed interval because it cannot be differentiable at an endpoint. So that's open. From there, in both cases, you set f prime of x equal to the average rate of change along your interval. The only difference is that Rolle's theorem is slightly more specific, because in Rolle's theorem, the average rate of change has to be what? 0. But it's still technically the average rate of change, yes? It's just in order for it to be Rolle's theorem, it's all about when the average rate of change is 0, because your interval has to start at the same f of a value as an f of b value. They need to be equal. So it kind of dawned on me that Rolle's theorem is just a more specific version of the mean value. And in Rolle's theorem, like I said, for the mean value, we can take a curve and we can take a point, I'll make our endpoint there and there. So for the mean value theorem, who cares where they are, but the average rate of change is here, and we're looking for the moments on the curve where the instantaneous rate of change is about the same. This one looks like it has 2. That's the mean value theorem idea. Whereas Rolle's theorem has to start and end at the same level, so that the average rate of change in the secant line would be a flat line, in which case you're always looking for, really, a max or a min, a relative max or a relative min. Capiche? Does that make sense? Okay. So getting into the increasing, decreasing stuff a little bit more. Find the open intervals along which the function is increasing and the intervals along which the function is decreasing, okay? Functions change whether or not they're increasing to decreasing right when the slope is 0 always, yes? So a function is going to kind of change its increasing to decreasing or vice versa anywhere where the slope is 0 or anywhere where the slope is undefined. So for example, if I have or the function is discontinuous, if I have a rational function, just a generic form here, on either side of this asymptote, which is obviously a point of discontinuity and a point of non-differentiability, it's increasing on the left, and it happens to also be increasing on the interval to the right of it. But we do have a break in action right there because it's neither increasing nor decreasing right at that point. Or likewise, you could have a rational function that's split like this, and along the interval to the left it's increasing, whereas along the interval to the right it's decreasing. So we can have a change from increasing to decreasing or vice versa anytime the slope is 0, increasing, changes to decreasing, or anytime the slope is undefined or the function's not differentiable or something of that nature. Is that clear? Okay? So when we're trying to find these intervals along which it's increasing or decreasing, we really want to find the moments where the derivative is equal to 0 or equal to undefined, in case we have a kind of a funny case there. So I'm going to take this derivative, which is 3x squared minus 3 halves, and I want to find where this is equal to 0 or where it's undefined. Now, hopefully we can look at this and show that it's never going to be undefined, right? This is always defined. So never undefined, so we don't have to worry about any critical points coming from there. But it will equal 0, maybe. Solve that. Add your 3 halves. Divide by your 3. And square root both sides. What are the x values? Paul? Right, plus or minus the square root of 1/2, which you can rationalize if you want to. That would be 1 over root 2, which would be plus or minus root 2 over 2. So those are the moments that our slope might change from increasing to decreasing or vice versa. It doesn't have to. We still have to test for that. So this is where we're going to set up a number line. And positive root 2 over 2 is going to be on there, and negative root 2 over 2 is going to be on there, because at those moments we know that the slope is 0. You don't have to write that little 0 up there. So it's neither increasing nor decreasing exactly at those moments if the slope is 0. But what we're interested in is it increasing or decreasing in this interval prior, in the interval in between, and in the interval after? So let's say, like right here, give me an easy number that's between these two. 0, okay? How are we going to find out whether or not this function is increasing or decreasing at 0? Plug 0 in where? If I plug it in the original, it's going to give me the point. It's going to give me the point on the function 0, comma something. That doesn't tell me increasing or decreasing. You're right, the derivative, increasing or decreasing, that question is a matter of what's the derivative. If the derivative is positive at 0, then it's increasing there. If the derivative is negative at 0, that means it's decreasing there. Replace the word derivative with slope. If the slope is positive at 0, it's increasing. If the slope is negative at 0, it's decreasing. So when we plug 0 in also, we're not concerned at all about the number that we get, other than is it positive or negative. Follow? So if I plug in 0, what am I going to get? A negative number. That's all I care about. A negative number. Who cares about the value? But it is going to be negative. So this is an interval along which the function is decreasing. So we plug in checkpoints to the derivative, just as a note there. Now, root 2 over 2, we don't know exactly what that decimal is, but it's 1 point something over 2, so let's pick a number that's greater than root 2 over 2. What did you say? 3. So Owen crushed it. He picked something that's much greater, but that's fine because we don't have like another thing that we need to stay under. Plug in 3. What do we get? A positive number or a negative number when we do f prime of 3? Positive. So I'll actually write this as well. F prime of 0 equals a negative. F prime of 3 equals a positive. And on the flip side, we'll go underneath negative root 2 over 2 and maybe just plug in negative 3. What's that going to give you? Also a positive. So, now you can tell me, this is increasing from negative infinity up until this. It's decreasing from here to here, and then it's increasing again from here to here. So, increasing, our interval will be negative infinity to negative root 2 over 2. Around infinities, we always use parentheses. What am I going to use around the negative root 2 over 2, parenthesis or bracket? Is it actually increasing right at negative root 2 over 2, yes or no? No, it's not, because the slope there was 0, so that's a parenthesis. And I'm going to write a union with the other interval it's increasing along, which starts at root 2 over 2, again with parentheses, and to infinity. And my decreasing interval is just from negative root 2 over 2 to positive root 2 over 2, again both with parentheses. Any questions on that? Does that make sense? Hopefully. The other thing I'll say, and I talked about this on the first day, is that this is actually how you're going to find out if this point is a relative max or not, okay? Because if something increases and then starts to decrease, as long as the slope is 0, right? If the slope was undefined at that checkpoint, that would be a different issue, right? Because if the slope was undefined there, it might be something like this. So we don't have a relative maximum there. But if it goes from increasing to decreasing surrounding a slope of 0, that has to be a relative maximum. We will run into cases like this, where we check this and it's positive, and then we check this interval and it's still positive, even though it had a slope of 0 in between. And that would look like something that was increasing, evened out at 0, so it was a critical point, but then continued to increase. And that is not a relative max or min, because there was no change from increasing to decreasing. Do we follow? Okay? So you have to check every interval. Although most of the time, I won't lie to you, you'll figure it out. Most of the time it does flip-flop every other. This is absolutely, what I just showed here is absolutely a possibility that you have to be aware of. That's kind of that question we did the other day where draw something that's a critical point but not a relative max or min. Would look like that. All right, number 2. Again here, we want to take the derivative. What is the derivative of the cosine of x over 2? Oh, Bryce C. Very good. So we've got a chain rule in there as well. So when I clean that up, I'm going to make it negative 1/2 the sine of x over 2. So when is this undefined? Never. The sine is never undefined, unless that x happened to be in the denominator. When will this be 0? So that's our other question. Negative 1/2 sine of x over 2 equals 0. I pretty much can divide that negative 1/2 on both sides, and I'm still looking for where the sine of x over 2 equals 0. And our x's have to be along this interval. So, not including 0, right? But beyond 0. What's the first thing x could be that would make this 0? Pi. If I plug in pi, that's the sine of, ends up being the sine of 90. So 2 pi, right? True, but that still sets, so there's no fluctuation in between, and we would never say it's increasing or decreasing right at those endpoints because they're out of interval, but what is happening between those? Right? We still got to assess, even though the whole thing is limiting us to this interval, we still now, that just gives us our interval. We only have to test 1 point, and why not make it pi? If I plug pi into the derivative, do I get a positive or a negative? Positive. So we only have one increasing interval, and that increasing interval is from 0 to 2 pi. I'm going to quickly graph for you the cosine of x over 2 on the interval from 0 to 2 pi. I'll count by pi's over 2. Negative 2 to 2 should be fine. And here's what the graph of it looks like on the interval. And we can confirm, what just happened? I know what happened. Did we plug pi into this? That was once we started solving. We should plug pi into the derivative. You knew something was up. You should have spoken up. So the sine of pi, yeah, that's a good lesson for us. Don't plug it into what you were doing to solve. Plug it into the original derivative cleaned up. So the sine of pi over 2, of course, is 1. But with a negative 1/2 out in front, it's a negative slope in that interval. And then, obviously, our graph is confirmed. It's decreasing the entire time. Good? Just for the sake of checking that last one, x to the 3rd power minus 3/2 x. On my window from, I'll just make it a standard window. Okay? It's increasing from negative infinity up until some value that's hard to tell, but we can kind of see that it's negative something. Negative root 2 over 2, obviously. And then it starts decreasing from that negative root 2 over 2 to positive root 2 over 2. And then it starts increasing again from root 2 over 2 to infinity. Good? Any questions there? How are we doing on time? All right. We're going to skip these two. We'll come back if we have time, but really briefly at the bottom. If, and my if got punched out by the hole, if the derivative is less than 0, aka negative, for all x in the interval, then f is increasing or decreasing? If the derivative is negative, it is decreasing, because that means that the slope is negative. That's decreasing. If the derivative is positive, then f is increasing. Okay, and there's our quick step process. Find the same critical numbers that you found the last time. And like I said, I did talk about this regarding like finding just one time on that first day of notes, but really that first day of notes and what you're going to be on your quiz tomorrow is more about absolute max and mins. So testing all the critical points and seeing what's an absolute max or min. And only today and beyond are we getting into relative max and min, like truly finding out what's relative and what's not. Okay? On the back, again, just another name for it, but we're seriously doing the same thing. A first derivative test is a test used to find the relative extrema of the function. So that first derivative test is still finding the derivative and setting it equal to what? 0. You're not going to be a relative extreme. Just kidding. Take it back. You're setting it equal to 0 or you're setting it equal to undefined. Because there is one case of having an undefined slope that would still result in a relative extrema. What would that be? Absolute value. Good, Jenna. Something that you still have a relative minimum there. So you still do need to think about where the derivative is undefined. But know, honestly, that that's only going to come up if it's an absolute value question. God, that might not even be true either. Because sometimes these graphs kind of do weird things like this. Yeah. So absolute values, and actually as we get more exposed to these kind of functions that are raised to a rational power, it actually can create weird points as well with that. So we're just going to stick with f prime of x has to be set equal to 0, and f prime of x has to be set equal to undefined, and then, so that's step 1. And then step 2 is going to be testing your intervals. Now, if your derivative is undefined due to an asymptote, now you definitely do not have a relative max or min there. Okay? I'll show you the picture that I drew on the other side. Asymptotes cannot create a relative max or min at that point of an undefined slope because there's no point on that line. There's no continuity going on. So in our number 1, find the derivative. Oh, geez, Louise. Sam, help me out. The derivative. Welcome to class. Perfect. Now, again, we're on this interval. We want to know where this is undefined. Where is it undefined? Never. Cosine is never undefined. Where is it equal to 0? So that's going to be 1/2 equals cosine x. Along the interval from 0 to 2 pi, so first I'm going to remind myself what quadrants I'm limited to because cosine is only positive so often. And so what's the first quadrant angle at which the cosine is 1/2? I know what you're thinking. Pi over 3, good. And again, so we need the pi over 3 angle in the fourth quadrant as well. What would that be? Yes, Brycey, say it. Can see you like mouthing it. You're thinking still, but I think you have it. Oh, you don't? What has a reference angle of pi over 3? This is 3 pi over 3. This is 6 pi over 3. So what would 1 back be? 5 pi over 3. Those give us our potential relative extrema. We cannot confirm that they are or are not until we do our test. Keeping in mind that we cannot go past a 0 and we cannot go past a 2 pi. So when I'm picking something less than pi over 3, make sure it's still greater than 0. So give me an angle that's less than pi over 3 but still greater than 0. Pi over 6. Pi over 6 can work. So what is the cosine of pi over 6?
Radical 3 over 2.
1/2 minus radical 3 over 2. Is that positive or negative? Is root 3 bigger than 1 or smaller than 1? Bigger, so it's 1/2 minus something bigger than it, so this is going to be a negative. What can we nice and easy pick between pi over 3 and 5 pi over 3? Okay. No, pi over 2 is fine. Cosine, 1/2, this will be 1/2 minus, what's the cosine of pi over 2? 0. 1/2 minus 0 is a positive number. And what can we choose between 5 pi over 3 and 2 pi? 6 pi over 4 is 3 pi over 2. 11 pi over 6 would be fine. So if I choose 11 pi over 6, That's a reference angle of pi over 6. The cosine of pi over 6, again, is root 3 over 2. We're in the fourth quadrant, so that stays positive. So again, that would be 1/2 minus root 3 over 2, which would be a negative. So, is pi over 3 a relative extrema? Yes. Which one? A relative min or a relative max? Min. It's decreasing coming into it and increasing coming out of it. So relative min is pi over 3. And what about 5 pi over 3? It's increasing going into it and decreasing coming out. So relative max at 5 pi over 3. If they want to know the full point, that is the relative minimum point versus the relative minimum location, we would obviously have to plug pi over 3 into what? The original to find the point on the curve, correct? And that wouldn't be a nice number. You'd have to leave it in terms of pi, as far as the 1/2 times pi over 3 would be concerned. But how are we doing? How's that sit with you?
Really well.
Good. Find the derivative of number 2 on your own. What? It's not even hard. You're just being overwhelmed. Is that what we all got for our derivative? Yes? When does it equal 0? When x equals 0. When is it undefined? Plus or minus 2 is going to make our denominator 0. So those are our critical points, at which, again, we have an undefined, and a slope of 0. Are those, well, that's when our derivative is undefined. Is our function actually undefined at plus or minus 2? No, right? 0 to the 2/3 power. So it's not an asymptote. Our original function's not undefined. So we do have a point there. The derivative is likely undefined just because this comes to a corner point. Okay? So let's assess a -3. If I plug in -3 into this derivative, my numerator is negative, divided by my denominator is what? If I plug in a -3, is it positive or negative? -3 squared is? 9 minus 4 is? Cubed root of a positive is a? Positive times a 3 is a? Okay, and a negative divided by a positive is a negative. From -2 to 0, plug in -1. That'll be a negative numerator. What's going to happen to our denominator? It's gonna be negative, because 1 minus 4 will be a negative number. We can take the cubed root of a negative number, it's still negative, a negative times 3 is negative. And then a negative divided by a negative is overall a positive. What's gonna happen when I plug in 1? A positive on top over a negative on bottom. That's going to be a negative overall. And what happens when I plug in 3? Positive on top, positive on bottom. So, given that even though these have an undefined slope, they're not undefined function values, tells us that we can still treat these as a minimum or a maximum. Versus if these were undefined points in your original, there would be no point there, so you couldn't treat it as a relative max or min. But we do have a relative minimum at -2, a relative max, a relative min again. And I'm going to take a minute to just type that in so you can see what that graph looks like. Oops. This is only taking me an hour to plug this in right. Okay, here's the graph. Hold on. Do we agree? Relative minimum? Relative maximum? Relative minimum. Spot on with what we found. Okay? Let me take a peek. I should cut that down.
Yeah, we did 4 in this. I think we should do like 4.
Well, I don't know that they're all that hard.
They're all that hard. I imagine they're hard enough, but I don't guarantee it.
No, 1 through 7 is just looking at the graph.
So like 3 questions. My bad.
Hold on, you know what? Let's do 1s and 5s.
Alright.
I never wrote it down last year, but there was one assignment where the kids were like, that was ridiculously long. It might have been this one. So we'll make sure you're okay with that cut down a little bit.
Good. I was up till 11 last night getting the homework done, and then I left it on my desk.